Okay. Here we have a log, which I'm going to model as a particle, and this time it's resting on horizontal ground. So let's have a look at the forces which are acting. Now we're told that the mass of the log is 80 kilograms, so the weight, which is acting vertically downwards, is going to be 80 g newtons. Acting upwards, we're going to have the normal reaction, so that's acting in an upward direction there, and we're told that the log is being, it has a force of magnitude 240 newtons applied at an upward angle of 20 degrees. So that's going to be something like this. So there's my 20 degrees. That force is 240 newtons. So there's 240 newtons, and that's acting at an angle of, 20 degrees. Now we're also told that the log is on the point of moving. Now, if it was on the point of moving, it's being pulled to the right. It means that the frictional force must be acting to the left, and because it's about to move, that frictional force must be a maximum. So I'm going to show that as going towards the left here. We have got the maximum frictional force, and the question asks us to calculate mu. Okay, first of all, I know that the maximum possible frictional force is equal to mu r. So the first thing I'm going to do is calculate r. And I know here that the forces which are acting upwards are going to equal the forces which are acting downwards. All right, acting in an upward direction, we've got r, but we've also got the component of this force, which is acting in this direction. That angle there is going to be 70 degrees. So acting upwards, we've got r plus 240 cos 70 degrees is going to equal the force acting downwards. Well, that's just going to be equal to 80g. So I know that r is going to be 80g minus 240 cos 70 degrees. In other words, my F max is going to be mu multiplied by that. So mu times 80g minus 240 cos 70 degrees. Now I know that it's in limiting equilibrium, but that's the same as any other equilibrium, and I know therefore that the forces acting towards the right must equal the forces acting towards the left. Acting towards the right, then, we've got the component of this 240 Newton force acting to the right. Well, that's going to be 240 cos 20 degrees, and that's going to equal the force acting left. Well, that's just F max. And I also know that my F max is equal to mu times that thing in the bracket. In other words, mu, the coefficient of friction, is going to be the 240 cos 20 divided by the thing in the bracket. Well, that's my 80g minus 240 cos 70 degrees. And if I work that out, it comes out as 0.321.